Good morning everyone, this is Kavipriya from SNS College of Allied Health Science, Department of Cardiac Technology. Now the topic is about cardiac action potential. Initially, the cardiovascular physiology has an depolarization, repolarization and hyperpolarization phase which is get initiated by this action potential. Okay, the cardiac muscles, there are some types of cells are presenting, smooth muscles are there. They having gap junctions. Within the gap junctions, the ions are exchanging. Ions exchange are happening. So it is the action potential also be there. So here the cardiac action potential is deep in curve. See, this is cardiac action potential curve. Initially first is an influx of sodium happening, then potassium, then calcium, and then again efflux of calcium happening. So it is a hyperpolarization, repolarization, which means relaxation state gets started. Initially it is relaxed in phase, the cardiac muscle is relaxed in phase. Then the influx of sodium can cause the muscles get contraction, depolarization. Then again sodium and potassium level increased in inside of the cardiac muscles will cause depolarization, and again increased level of ions which will move one cells to another cell using gap junction. That time the again cardiac muscles get repolarized, that is calcium channels close and the efflux of potassiums can be happening. So that time the hyperpolarization or repolarization gets started. See, what is cardiac action potential? It is based on electrical heart function, and it is due to ionic movement of heart. And again this is cardiac myocyte structure which is in here. This is cardiac myocyte. It has an gap junction. So in between there the exchange of ions will be happening. So we can observe action potential, that is depolarization and repolarization. See, it is intercalated disc and gap junctions are present in cardiac myocyte, and the functional syncytium, that is atria and ventricle. It has an T tubules and sarcoplasmic reticulum. Again immediate physiological effects are initially the phases of cardiac action potential we gonna seeing now. So the phase 0, initially it is 0 in phase, that is depolarization. In that there is a rapid sodium influx will be happening. Influx means infusion of sodium ions. So there voltage gated sodium channels get opened. Then again membrane potential reaches, initially it is 0. So now the membrane potential reaches the plus 20 to plus 30 millivolt, and there is an upstroke velocity happening 100 to 200 millivolt per second. Then again phase 1, for initial phases about depolarization, and again now phase 1, that is initial repolarization, that is transient potassium level get effused. Inactivation of sodium channels, initially the sodium channel get opened and influx of sodium has been happening. Then now inactivation of sodium channels and activation of transient outward, that means efflux of potassium ions, potassium channel, that is phase 2. There is plateau phase, a calcium influx and balance the potassium efflux. Efflux means ejections. L type of calcium channels are opened and it prolong the depolarization, that is up to 200 to 300 millisecond. Phase 3 are repolarization, rapid efflux of potassium ions, that is inactivation of calcium channels and activation of delayed rectifier calcium channels, and there a resting phase also be happening. Phase 4, resting membrane potential get stability of diastolic, that is inward rectifier of calcium channels, and it maintain the 90 millivolt, voltage is about 90 millivolt, minus 90 millivolt. Now sodium and potassium channels are restore the ions inside the cells. See, this is action potential curve. Potassium and sodium channels are out. Calciums are also in inside the channels, or it remains unstable, so it is called as plateau phase. Then voltage gated sodium channels, phase 0, obstruction happening. Then again L type calcium channels are opening in plateau phase. Then phase 1 there is a repolarization. Phase 3 there also in repolarization, that is obstruct will be happening. Then inward rectifier phase 4, resting membrane potential remains unchanged. Then dysfunction causes the arrhythmias. If action potential will not regulated properly, it does cause arrhythmias. because action potentials are happening in pacemaker cells. The various of locations is about atria, ventricles and Purkinje fiber. It affect the heart rate, autonomic tone and drug disease, and it is prolonged due to the early after depolarization, and it is shortened due to re-entry of arrhythmias. So refractive period, it is Naras Nobi, corresponded to 0 to mid third phases. It ensure the unidirectional propagation and prevent the re-entry. So relative refractive period is very strong, its stimulus is needed, and it is correspond to the late phase, and it has increased the risk for arrhythmias. Thank you all.